So let's invite our next speaker to our studio. Our next speaker is Peter. Peter, welcome to Java On 2033.
Hi, Peter.
Hey guys, how are you doing?
Good, good. Welcome.
Cool.
Yeah,
We are waiting
so
for you.
yeah, so it was nice first talk, and now we proceed with your talk. So can you maybe give us some hints? What would it be about?
Um, how about we jump right into it then?
Okay, that's a good answer. Okay, so before we jump right into it, guys, just a reminder, we have online activities. You may find everything on our platform. On YouTube and on the platform, we have chats. So please leave us your comments, questions, everything there. We will try to ask all your questions to Peter in the end of the talk. I hope we would have time for that. Still, please send us your comments, reactions, everything there. We monitor both chats and we are there. So yeah, let's not waste time anymore. Yeah, Peter, we can see your screen. We will ask our operator to show it to us. Yeah, good luck. Let's go.
Hey guys, and welcome to my talk, which is named AI A to Z. So to answer the previous question, what it's about AI and basically everything about AI. But before we do that, let's talk about a topic that is one of my favorites and talk about me. Who am I and what gives me the right to talk to you about AI and everything? I used to be, or I hope I still am a Java engineer, like most of you, since this is a Java conference. But since the beginning of this year, I had the chance and the privilege to lead one of EPAM's AI POC team. And during the course of this year, I had the chance to work on and create dozens of prototypes based on all kinds of AI technologies and to be involved in pre-sales process, interact with clients, also attend leading conferences and have very interesting discussions in technical leaders. So what we're gonna do today is have a very nice reduction of everything that I know, and I will answer a couple of questions that I've heard during the last year, and engineers like you ask me, and like, how to get into AI, what should I learn, where to look at, basically, if I want to be involved in this very trendy field. Let's go to the next slide. Wow. But before we do that, we have to answer a very simple yet profound question. What is AI? The easiest answer I can give you. Artificial intelligence can be any process, any procedure that indistinguishable from human actions. Even if you have a fixed set of algorithms, but you cannot really tell the difference if what is happening is done by a human or a machine, that can be considered AI. But AI comes with its risks. And this is the part where I give you this very interesting quote. I'm not afraid of machines. I don't think the robots are taking over. I think the men who play with toys have taken over. And if we don't take the toys out of their hands, we are fools. Ray Bradbury. I got a good news for you. We are the men who are playing with these toys. And as Ben Parker said, with great power comes great responsibility. Every time we are interacting and working within this field, we have to be very conscious about our actions. And listen, I don't tell you not to take a job. That sounds interesting, maybe a bit dangerous. But all I ask, if you're in this field, at least please don't create Skynet on purpose. At least on purpose, like that wouldn't be so nice. And let's jump into the history of AI. Since the beginning of time, humans and humanity is thinking about machines that work and think like us. In ancient Greek, Hephaestus breathed his life to its helper machines that were just like our modern robots. Millennia later, we've seen sketches from Da Vinci about a mechanic knight that can take over the task of fighting for them. And in modern pop culture, we have the familiar names in every household, like C3PO and R2D2, which are the latest iteration of humans looking for autonomous machines. We are trying to find similarity in everything. In modern history, we have a couple of key points in time that developed our thinking about AI. In 1950, first we were introduced the idea of the Turing test. The Turing test is basically what I've said in the beginning of this presentation. If you cannot distinguish the actions of a machine from a human, then we achieved artificial intelligence. But interestingly, at that time, we haven't had the definition of artificial intelligence yet. We had to wait another 6 years. In 1956, in the Dartmouth workshop, a couple of scientists, computer scientists, came up with the definition of artificial intelligence. Later on 1966, we had the ELIZA project. This was the first natural language processing autonomous machine, or AI, and this is basically the great granddaddy of JetGPT. In 1997, IBM's Deep Blue managed to defeat Garry Kasparov in chess, who was the reigning grandmaster at the time. And we jump into 2012, the ImageNet competition, which was a big breakthrough in image recognition. And the latest iteration and the pinnacle of artificial intelligence science at this point is OpenAI's GPT. But what enabled us to achieve these breakthroughs and have this technology that we all cherish today? Basically, I would like you to understand that computational capacity is key when we are talking about AI. And modern CPU architectures played a big role in this boom that we've experienced in recent years. I personally think that vector processing is a very crucial part of how AI works and what we are doing. It reduces the time to get to the right calculations. We're going to go into detail a bit later on, why and how is it important. But all you need to know that previously we had different kind of computational units within our CPU, and in recent years we got introduced this vector computational units in modern CPU architecture, which was a huge breakthrough for our neural network models and things like that. Parallel computing also played a huge part in it. And modern GPUs, which you all know, most of these computations are running on GPUs simply because of their computational capacity and because of their throughput. Also a huge part of what's happening right now. If you have looked at NVIDIA's shares in the recent years, you may see that they are growing exponentially. One of the reasons, because everyone expecting AI to be a huge thing, and to run anything that requires that amount of computational capacity, we need a lot of GPUs. And I previously mentioned, we have to talk about neural networks. Neural networks, the term is coming from neuroscience, which is in biology, rooted in biology. And the idea was, if we want to mimic human behavior, we have to copy the human brain. In sci-fi, you've probably heard the term positron brain. We are not there yet. We are not building actual brains, but we came up with a mathematical model that mimics the working of neurons and these connections between the neurons. What are neurons? These are the nodes within your brain that are electrical connections between them. And each time you are thinking of something or doing something, these connections became stronger and stronger through the electric current that goes through it. And we came up with the idea that we can imitate this behavior with the help of mathematics and programming. And then this is how we came to the neuron. What is a neuron in computer science? It is an object and a connection between objects or nodes, which has several input fields, input variables. This is what you see at the left side on the screen. x0 to xn, we can have any number of input fields. These little W's is representing the weight that each of these connections or these inputs are represents. These are the weights that are basically just a number between 1 to 0, a correlation, which is the most likely route to take, basically, which is the most likely input variable that our node or neuron will process. And the neuron is nothing else than a set of, not even a set of, just a mathematical function. It can be anything. We can have different activation functions within a neuron, but it's basically just math. You get a number that has a probability to go into your neuron, and that neuron will do its work on that number and will have an output. And if we join these together, we'll have a neural network. What you see here is a very small representation of a neural network. And you can think about it this way. How does this work? You want to determine whether a color is blue or green. You represent this as a set of numbers from a list of numbers, 3 numbers, each of them from 0 to 255. And then you have these functions within it that are basically will act as if-else statements. And you can create a statement like, if the first variable is 255, the first number within this set of numbers, then we probably have a red color, which is neither green nor blue. So we can say it's none. If we have the second number, which is 255, we can say that is green. And you would be right, but if you would have the first number 0, the second number 255, and the third number 255, that's not going to be green, that will be yellow, I guess. So you have one connection that will have a certain weight, which is if the second number in this list is 255, then we have a probability that it will be a green color, but you will also have a set of probability to another node that expects and look at these two numbers in sequence, that if the first number, if the second number is 255 and the third number is 255, then we have yellow, which is neither green, neither blue. So that's not a good connection. That has to have a lower probability of activating. And if you go through this logically, you will understand that with the help of backward propagation and other techniques, we can weigh these connections between each nodes, and this is how we can get to a good color. But unfortunately, this is not enough. And I hear you say, but Peter, 5 nodes of neural network is a perfectly respectable size of a neural network. And unfortunately, and I say this with a huge pain in my heart, this is not the case. This is a field where size does matter. So let's go bigger. And it's freeze. Okay. And we are growing. But let's go even bigger. And I have to say, it looks much more better, but it's still not enough. Wow. It looks something proper right now. it is still a simple neural network, but a lot has been changed since we first seen a neural network. We have several layers now. We have an input layer, we have a hidden layer, which we hadn't had before, and we have output layers. Now, the whole idea is if you have several layers, you can process your data and transform it sequentially. And with each neuron, each connection that you are going through in the network, you come from a set of data, you will transform that data, and with that transformation, you're gonna go through another and another layer of transformation till you get to the right answer, basically. And here's the thing. I wish I could say that this is good enough, but we are greedy. We need more. And this is how we come to a neural network like this one, with several hidden layers. And this is mostly a good representation of what we are dealing with today. And as you can see, we have layer structures, a huge number of neurons, and everything else. I would like you to imagine that ChatGPT-3 has 178 billion parameters. Yes, that's right. And a parameter is basically the weights that are between each of these neurons. So it has billions of connections between these nodes. And I calculated that it has almost 100 layers. So there is no way to display it. And also hundreds of thousands of neurons. So these circles that you can see, those are the neurons, and it has hundreds of thousands of them, and the connections between them, it has billions of them. So such is the insatiable appetite of man. Even this size is not good enough for us. We need bigger. And with a bigger neural network, you can go deeper. And that's how we arrive to deep learning. And deep learning is nothing else than a huge neural network with even more refined layers. And with each layer, we have different things that we are processing. So what you can see at the bottom, by the way, is a CNN, a convolutional neural network, which is a deep learning technique that you can apply for image recognition. It's a very good technique for image recognition. And what differentiates a convolutional neural network from a typical neural network in our case is basically that it has layers that doing abstraction, pooling the data, creating the connections between the data. And if you think about it, we have to do it because if you have an image, that is nothing else than a matrix. With each layer in a convolutional neural network, we are introducing new dimensions to the image. One of the reasons is we have to understand the connections between each pixels, and that cannot be done with a simple neural network. We have to apply these techniques that is implemented within a convolutional neural network, which is called like a pooling layer. We have to have a preservation of spatial recognition and feature extraction. And this is how we get to, we have layers upon layers, and within each layers, we have subsequent groups that are designed to transform your data to have this higher dimension of understanding. And with the help of these new techniques, which is called deep learning, we basically introduce a new set of tools that are designed for certain tasks. As I mentioned previously, CNN, convolutional neural network, is used very frequently within image recognition. RNNs, recurrent neural networks, were very useful in natural language processing. Nowadays, they are a bit deprecated. We're going to talk about that, but it was a technique that was first introduced for natural language processing. Excuse me. And you can achieve beyond human level of performance with these huge neural networks. That's how we come to the large language models, which are all the trend today. So large language models, what's the difference? We talked about RNNs, which I told you that are useful for natural language processing, but what has changed? So a large language model utilizes a couple of new techniques. One of them, which I call transformers. Transformers introduced a attention mechanism within a deep learning process. And we already had some kind of memory in deep learning. We had, based on RNNs, we had long-term, short-term memory models, but it wasn't enough because attention is not just about, you have a certain memory, but you have to understand the connections between each parts and how they correlate together. So with the help of transformers, we introduce this attention mechanism. We have so-called feed-forward neural networks, near layer normalization. It's a whole bunch of things, but as you can imagine, as I mentioned previously, this will result in this monstrous of neural networks that has billions and billions of parameters and hundreds of layers that you cannot even comprehend. You literally have to build tools to understand what's happening within your neural network. And basically, this is the gist of it. You have a good overview now of the different techniques, where we are coming from in modern AI science. So let's display the capabilities of this technology. One of my favorite things is the Shakespeare generator, and I would like to read you this beautiful quote from it. Look, sir, that not this innocent mind, friends, and hateful dogs has appeared, for it excelling clouds with gentle natural plucking, the liberal dogs not this. Very nice. The Shakespeare generator is one of the early generations of a language model. It is based on RNN technology, which we've talked about, and it had a couple of issues, as you can see. It's not perfect, but you can also see that if you look far enough, it looks like Shakespeare, and if you have problems with your hearing, it almost sounds like Shakespeare. So what's happening here? Why we have these strange words that are not even English? Yet, if I read it to you and you don't pay attention, you would say, yeah, that was a Shakespeare quote. What's happening here is RNNs, and especially the data set that this particular Shakespeare generator was trained on, wasn't enough to understand all of the intricacies of English language. Therefore, it has no concepts of what is right or wrong grammatically, but it was able to create a correlation network between each letters and each verse. So the probability, as it seems, there is a high probability that after the word look, the following word will be sir. That's all it is. I wanted to show you this because it's very important to understand the mistakes of these early models, because the remnants of it still present, even within ChatGPT. You can see how it correlates things. You can see the mistakes that it makes. And if you have practice within this field, you can mitigate these issues very easily. And to do that, I implore you to go and check this link out, where you can find a notebook and you can code alongside it. You can create your own Shakespeare generator. You can get all of Shakespeare work downloaded by free, but also you can train this model on anyone else's works, basically, and let's see what you can come up with. It's good fun. I highly recommend. It's like takes about an hour hour and a half, and you will have your own homemade Shakespeare at your own disposal, which is fun. Oh, and let's move to modern techniques within these modern times. So we talked about the fundamentals within computer science, within AI sciences, with the neural networks, deep learning, and large language models. And with the wake of this generative AI hype train that we are all sitting on, we had to come up with new techniques to mitigate other problems that these models have. ChatGPT has a certain memory. It has what we call a context that can keep in mind, but it doesn't have real memory in terms of it has knowledge because they trained it in a huge set of data, and it can mimic like it has knowledge. But if you want to introduce your own data, after a while, it's going to forget and it cannot interact with it. To mitigate this issue and to introduce our own data within to these language models, we came up with, not we as humanity collectively came up with this new technique, which is called RAG. And as you can see, I became creatively bankrupt by the time I got to this slide, and my best idea was to put an actual image of a rag as a background, and decided against it. So you will have this boring background, black background instead, but at least I animated all of the slides. So the RAG model, what it is called retrieval augmentation generation, retrieval augmented generation. And the whole process is the following. We had our data storage. It can be a data lake, but let's just call it in this case input documents, data source, whatever. We go through and we go through and process all of this data that we have, transform them into text, and then upload everything into a vector database. A vector database is a new type of, relatively new type of database that works on vectors, creates these collections and vectors based on the embedding models that you introduced. You can use, for instance, a semantic embedding model, and then you enabled basically semantic search on your database. I'm not gonna go into much of detail because vector database are like an hour-long discussion in and of itself, but it is a technology that you should be familiar with, very, very useful. And this is the fundamental, one of the fundamental parts of a RAG that we are using. When you hear these words, by the way, what are chunks and things like that, you have to split up your documents because you have to respect the token limits. And basically what we are doing here is when we have a user query that comes into our application, we push, we first give this user query to our vector database, and which are in this situation, let's say, is created with the help of a semantic embeddings model. And based on the semantics of our query, the database will give you back a set of documents, a set of these chunks, based on what is the most probable chunk to contain the answer to your question, which is very cool. And then you grab those documents and feed it to ChatGPT and say, hey, ChatGPT, I have this user query and I have these documents. Please answer this user query based on the documents. And this is how you introduce basically memory to your LLM models. And we have some rendering logic at the end, and you will get back the answer. And if you look at it, I mentioned LangChain. LangChain is a new technology. I could mention a lot of other of these agent tools that we have nowadays, like AutoGen and things like that, which is one of the latest and the greatest. But let's stick with LangChain. It's been around for a while, at least since the last year. It works pretty well, and it has, based on the LangChain agent workflow, I can describe it to you what these techniques of working with agents entails. Basically, you have your user query, and you don't want to just push your user query to the LLM. You want to wrap it into a master prompt. This master prompt looks like the following in most cases. It starts with, you are a helpful AI assistant agent. Help answer me this question. You insert your query in it, and then your long-chain agent gonna go to ChatGPT with your query and say, hey, ChatGPT, I'm a useful assistant agent. Help me solve this problem. Break this user query down into separate steps so that I can execute, so I can get back the right answer to the user. And this process is completely out of our hand. This is a communication between our application, the prompt, the agent, and between ChatGPT. And with the help of ChatGPT, Longchain will initialize different agent types. Each agent type has different tools, and each tool has a certain purpose. So you can say, hey, agent, help me create a financial report on, for instance, the Tesla stock. What it would do, it would wrap this query, push it to ChatGPT, then initialize a couple of these agents. One of them would be, for instance, a search agent, which does search on the Google API with the help of the SERP API. The other one would be an analytics agent that does calculations with the help of some Python library, and then you have to generate it. You would have another agent for that. And basically, this is a you're gonna go through this process a couple of times, and hopefully you're gonna get back with the right answer at the end of the day. This process actually works pretty well. I personally built a lot of these agents. I have a couple of these agents continuously running on my own machine. The only downside is the token limits are there, or especially you have to pay a lot for OpenAI's APIs. But it is what it is. Sometimes a task just to generate a financial report could take me like $5 each, which is quite a lot. But if, for instance, you are trading in your spare time, maybe it would be something to look into, because it helped me greatly to reduce the time that I'm spending on analyzing, for instance, basic financial data. Alrighty, so we just ran through a lot of these techniques. I give you a highlight of what are the available technologies, not in great detail, by the way. And why did I do that? So I wanted you to have a context within which we can talk about one of the questions that I've been asked a lot during the last year, which is, hey, Peter, you are working in AI, and I am a Java engineer. I want to go into this field. I'm very interested in it. What are the ways that I can take? What avenues are open for engineers like us to go and work with these latest and greatest technologies? And what I've realized that people don't really understand how big the AI field is and how many ways you can work within this field. Let's start with the most obvious and what is the most frequently requested, a data scientist. Data scientist is someone who's working on transforming, quantizing, cleaning the data, and sometimes even creating the models for these neural networks and applications that we have create. Bad news is, in this case, it is not easy to go from engineering to data science because your knowledge as an engineer doesn't necessarily translate well into this field. Meaning, what you need to know if you want to be a data scientist is a lot of statistics and mathematics. That's all it is. That's all it is. But here is the thing: if you are a senior engineer, for instance, you cannot really go and apply a senior data scientist position for another company. You have to kind of start over and say, hey, I take this hit. I start as a junior data scientist, but within a few years, you can, climb up within the career ladder. That's the bad news. The good news is the salaries are quite competitive within this field. So even if you go into a junior position, you might not take as big of a hit in terms of salary than if you would go to another junior engineering position. So data science, very interesting, very, very useful. It is basically one of the fundamental parts of modern AI, but as an engineer, it's not easy to transition. But there is the next opportunity, which is AI model developer. And probably this is something that you all think about, that I am going to create this next revolutionary model that I can, will destroy or save the world, whatever you're into. But basically, at this point, what we have, your knowledge as an engineer will translate quite well, not perfectly, into this field. So you don't have to take over completely, but you still have to have a lot of knowledge of statistics, because understanding activation functions and things like that is not easy. So if your mathematics are not up there, this field probably not for you. But this is one of these all-time favorites that you can go and work for. Any number of companies to creating their new models, and there are a lot of pre-trained models, pre-made models. You just have to tune them sometimes, but it involves a lot of programming, and most times you work very closely with data scientists in this field, so they can help you even with the math if you are not really good at it. So it is definitely something that you can and should consider as a Java developer if you want to transition to this field. It's a if it can be an easier transition than go to data science. Then we can talk about something that most people don't even think about, which is hardware specialists. Now, as most of you, hopefully, most of you are Java engineers, you probably heard about the JVM, and hopefully you've heard about projects like the Panama project. Basically, it is not trivial to execute code optimally on modern CPUs. So most of these models that you create and write in Python, for instance, with the help of TensorFlow, are actually then translated into native, so translated into C, and run as a C code, because there is no other way to interact with the vector computational units that I mentioned previously in this talk. And the whole point is to be specialized to translate code into native is very interesting. And in the case of Java engineering, this is what they do at Oracle. They are working on the JVM and trying to find ways, like within the Panama project, how to make Java interact with these new vector units without actually invoking C or native code. This is a very interesting and a very hard field to go into it, but it's just poor programming. Plus, you have to understand CPU architecture very well. So I think it's a very interesting field, to be honest. If I would be smart enough, I would work in it. Because yeah, I think it's just cool, and this is the foundation of everything that we are doing. By the way, recently we just got the news that Microsoft have created their own, architecture, CPU architecture, and dedicated to AI processing. So it is also something that it is a very competitive field, and it's growing at the same pace or even faster than the whole AI field. And the last, but not least, and this field, this pathway can be the most interesting to you, is AI application specialist, which you can call the prompt engineer or whatever. Good news, it's just programming, basically. You create applications with the help of AI and build your applications upon these new models and new techniques. This is what I do on a daily basis, or mostly what I do. And it is cool, very interesting. With these new accelerators and the help of these new accelerators, we can create applications like, portion of the time that previously I mentioned that interacting with data lakes is also something very interesting with AI, because it doesn't matter anymore if you have structured or unstructured data. The AI can sort it out. The only thing that you have to consider in that regard is performance, for instance. So I highly recommend to start playing with AI, build applications on top of these AI models. And connecting to ChatGPT is not hard. It's just an API call, nothing else. You write your prompt and you send it to ChatGPT, wait for the answer, and you have a mini application. And maybe if you introduce these agents that I previously mentioned, you can create more complex applications or applications that are capable of doing really, really cool stuff. So you have now the understanding of how AI works, what are the avenues that you can take, but you would probably want to understand what is the hype all about and how long it will last. So, interesting question. The answer is not as interesting, unfortunately. It's money. As it always, it's always about money. With their infinite wisdom, all these central banks has printed tons of money in recent years, which surprisingly led for higher interest rates. It's like, in Hungary, the governments always get surprised when there is snow in winter. It's the same with central banks. They always get surprised when they print a lot of money and then, oh my God, here is inflation. No one expected that. But with higher interest rates comes the burden on companies to have more profitable projects. Before 2022, 2021, we had an economic environment where interest rates were virtually zero. Therefore, any project that you pulled up had like a couple of percentage of profitability were greenlit by stakeholders, because any number is infinitely greater than zero. This is not the case now. It is very hard to find projects that can, not very hard, but it's harder to find projects that can make more money than the interest rates on the loans. And most companies take out loans, and this is how they fund their projects. And you can also, if you have money and just put it in the bank, and the bank has high interest rates, then why would you spend your money on less profitable ventures like that project or something like that? So that's one of the fundamental reasons that there is this huge hype around AI, because one, we got these technological breakthroughs in the 2010s. In 2020 with the help of ChatGPT, but also the environment changed drastically how these tech companies invest, and that led to this very interesting culmination of things, that there is this new technology which became a buzzword, and no one else is willing to spend on anything else than on this buzzword. One of the reasons, because AI is an accelerator, so theoretically you can do much more within the same time frame, meaning you can be much more profitable at the end of the day. And with that, I would like to mention the Gartner hype cycle. I'm not going to pull this up because it's very simple. That is the beginning of the technology. Then there is a hype where the interest goes up. Then people realize that it's not that interesting, so the interest goes way go down. And then in time it will normalize, because people will understand that is useful, just not as useful as they thought it were. Such as the case of crypto or blockchain, sorry. Huge interest in the beginning. Everyone want to do blockchain, then they realize, but there are very limited applications of blockchain, and NFTs are not really cool anymore. So interest goes down, and people start to realize again that, but it's actually a useful thing to have a contract on a ledger, then that gives you much security and stability, and the security concerns around our modern day life can be solved with the help of blockchain. So interest comes up again. In this case, I don't think that we are top of or the peak of this interest curve, I think there are a lot of skeptics that has this in mind that, oh, it's just a hype, it's gonna go down. I think people don't realize the potential within AI and how much will it change how we work. So in the previous presentation, you've seen even 3.5 can generate code very, very fast. I personally do 10 times of the work that I did previously with the help of GPT. So if your teams are enabled with this technology, you should start really thinking how to restructure your projects, because one, and how to estimate your tasks. I would recommend this practice for any manager here that try to create a team that forgets about agile, that has a huge backlog, and push them to see what they can do with the help of GPT within 1 or 2 weeks, and somehow motivate them to do as much as they can, push them a little bit, and you will be surprised how much work can be done than previously. I think how we work, how we lead projects, these methodologies like agile will change in the next couple of years. So I think we are just the beginning of this hype cycle and not really gonna go down, because there are a lot of skeptics and a lot of people don't fully understand what's happening within this field. With that, we arrived a couple of challenges that I faced during the last year. One of them is bleeding edge stability. I've talked about agents and long chain, vector databases, and all sorts of things. These things are basically betas. Everything is under testing. People are rushing these new functions out, these new capabilities out. There is no stability. You can forget about it. You have to work around it. It is what it is. Unpredictability of responses. It comes from the nature of these neural networks. As I mentioned, these are all probabilistic models. So, expecting deterministic answers with probabilistic models is craziness. There will be variations within the answers. You have to work around it, and you have to rethink how you test your applications. If you don't want your application to behave like a human, then maybe you don't want to implement artificial intelligence, but stick to your good old techniques that generate the same answer every time that you run it. Performance is very interesting question. You either all of these models are very computationally hungry. There is nothing to do with it. There are things to there are ways to work around it, but it is something that you cannot really change. Just come up with new techniques like RAG, for instance. Process library, yeah, terrible. Documentations are terrible. Everything is deprecated. Nothing is up to date. I think the one of the worst experiences with Microsoft in this regard. They are really bad at documenting anything, and they are pushing a lot of half-baked features. But again, everyone is racing to the top, and this is the pace of evolution. You can introduce a new feature, create a new application, and within 2 weeks, literally, it can be deprecated. It happened to us. If you try to keep up the pace with this field, it will happen to you definitely. Data accuracy, it comes to the fact that if you are in data science or where anywhere else, it's very hard to come by good data. Again, such as life, you have to work around it, have to find new techniques. That's why you want to hire, for instance, very good data scientists to solve this issue for you. Right tool for the right job. This is one of the most interesting part, and this is why I said that I don't think that people really understand the capabilities of AI. One, they have a general idea what they want, so they say, hey, what is the answer to everything? And you say 42, and they're gonna come back with, yeah, but I want to get this answer by the help of AI. And you say, all right, we can do anything that you want. It's just a matter of time and money. And usually the clients at this point are gonna get quiet. The other end of the spectrum, when I had literal conversation with clients, when they asked my team to, hey, can you add these two numbers together with the help of AI? I'm like, sure thing, we can do that. But are you sure you want to do this? um, it is a very expensive way to do calculations and not the most reliable. So if you have a problem, like, classic, when do you want to use relational database, NoSQL, or a vector database? The same problem. Think about what you want to achieve and pick out the right tool for the right task. Don't push everything through AI. Only the task that makes your life much more easier with the help of these new models. And there are a lot of misunderstanding about this whole field. People don't understand what is neural networks, what is deep learning. Now you do. So thank you. And let's have a quick recap of what we were talking about. So we went through challenges, we went through the hype cycle, mentioned potential ways that you can take and avenues that you can go on as an engineer. We had a brief overview of how these modern AI models are working. We talked about the evolution and the history of AI and defined the basic definition of what artificial intelligence is. With that, we came to the end of this presentation. Thank you, and let's have a Q&A session.
Thank you. Thank you very much for such a great presentation.
Wow.
Yeah, I'm impressed. I'm impressed. Just
Yeah.
applauses. Yeah, I think all our audience will join us. Before we'll jump to the question, I want to say thank you. And with your permission, of course, I will stole this thought from your talk. I just now I do understand that Douglas Adams in Hitchhiker's Guide to the Galaxy predict all these problems with AI. Like, what's the answer to the question of life, universe, and everything? So yeah, it's 42. So what's the question?
The question, yeah.
Yeah. So that's the problem. Wow, I'm really impressed. Thank you, Peter. Thank you very much. So we have some questions. Yeah, guys. So we encourage you to post more. We have time for that. So first question is your presentation made by AI? Peter?
Oh, sorry. I got zoned out. Could you please repeat the question? I was reading the comments and there are a lot of them. Sorry.
Yeah. So question is your presentation made by AI?
Yeah, definitely. Yeah. Not the animations. That was a lot of hard work, blood and sweat, and everything else. But all the pictures, animations were generated by AI.
Okay.
Yeah.
Okay. Great. Thanks for the answer. Next question is about unpredictability of response. A few days ago, OpenAI announced fixed seed mode that would allow ChatGPT provide reproducible results, specifically to make testing easier for devs. What do you think of that?
Yeah, this is comes back to the pace of evolution. To be honest, I actually watched and read this article, and it completely slipped my mind. So maybe it's not going to be a problem in the future. We haven't had the time to test it yet, so that's about it. Maybe it's going to solve it. Probably it will.
I fully agree, because they can something tell us, but we need to test it and be confident with any promotion from OpenAI of new features. So,
and don't forget that OpenAI and ChatGPT is just one segment. Like, it's a large language model, generative AI, but you can do much more. And they have many different models. There are many different techniques that you can utilize, and right tool for the right job. You don't want to use OpenAI or a large language model for everything. If you have a set of numbers, for instance, and you want to predict what is the next number, it's probably better to have a model that is designed to do that than to go through a large language model.
Okay. One more question we have. I will rephrase it a bit. So, are there, maybe some libraries for Java developers who want to work with AI and don't want to mess up with code in Python?
Definitely. So interesting, because last year I had to talk about AI with Java, and I was talking about DL4G. This is deep learning 4G. I think that's the best Java library for neural networks and deep learning as of right now. It is well documented, very easy to interact with it. I highly recommend to check this out. You can, do basically everything. You have preloaded models, and this is one of the advantages of Java, that Java is fast and you can go through the processes of transforming your data, what the model needs, very quickly, much faster than with the help of Python. Other than that, there are the TensorFlow library for Java, which is very poorly maintained, so it's very hard to work with it, but it actually works. You can do stuff with it. The problem is the documentation will be deprecated, or at least last year when I last worked with it, everything that they had was deprecated, and you had to figure out yourself how they work. There are smaller libraries that I don't want to mention because they are very instable, but yeah, these two are the best ones. The F4J definitely is something that you can even, I would say I would be comfortable to put it into any production. They advise against it, but I think it is stable enough. One thing that I would like to mention, with the help of ChatGPT, I don't think it matters anymore which programming language you are working in. You should be able to switch between them very quickly. So this shouldn't be, something that keeps you from working with AI. Also, I would like to mention, for instance, Milvus vector database. They have a Java library and Java support as well. So check this out. Fact check me on that, but I think that Milvus has Java library and Java support.
Okay, great. So, yeah, I just want to add to your last answer that we are all engineers and language should not be, but we are on Java conference still.
Yeah.
So let's
I'm trying
Java.
to keep silent because we're talking about Java. However, Python still exists.
Unfortunately, it exists. Yeah.
Okay, so I assume the last question before we finish this. What's your thoughts? Java developer role in the future will transform into application developer on top of AI or not?
Not necessarily on the top of AI. So let's think about this way. If you are working on a legacy application that still uses Java 5, which we know there are people there, and this is how I started my career, there are chances that you're never going to see AI within that role, and probably they're not going to let you use AI within that role. But I would say AI accelerated positions will be here because every company have to they have to overcome this problem with security, have to maintain their own instances of ChatGPT, for instance, or any of these accelerators like Copilot, and let the engineers work with it. And with the help of these accelerators, I think the role will transform more like a you have to be high seniority, and it's more like a full stack engineer, not dedicated Java. There will be some roles, like if you are working on the JVM, or if you are working on such low level applications, you want to really utilize all the good performance that Java brings to the table. I think in that case, you will be just a dedicated Java developer, but most of the dev roles, I think, will transform into this application developer, even if it's not on top of AI, because I mentioned AI is not good at everything. It's just good at most things.
Okay, great, Peter. Thank you very much for being part of Java On Conference 2023. We were glad for having you. Thank you very much.
Thanks, guys. Cheers.
Thank you. It's amazing.
Thank you,
It's
bye.
amazing tech talk. Thank you. Okay. We
Before we
covered.
start, we need to watch a video.